Hello everyone, this is Atulya classes, and guys, today we will start a new video about another reducing agent, and that is NaBH4, sodium borohydride or sodium tetrahydroborate. So let us start with this video. This is a very weak reducing agent. NaBH4 is a very weak reducing agent, milder reducing agent in comparison to LiLH4. LiLH4 is also a reducing agent. So NaBH4 is a weak reducing agent and it reduces very weak reducing agent. Reducing agent, and it reduces aldehyde, ketone into alcohol, aldehyde into 1 degree alcohol, ketone into 2 degree alcohol, okay, and acid chloride, it only reduces one of the acid derivative, that is acid chloride into alcohol. It does not reduce acid, that is carboxylic acid, or any other derivative like amide, ester. It does not reduce ester, okay. While we will be studying other reducing agents like LiLH4 in the next video, and that would reduce ester into alcohol. And one more we have read, that is sodium, that is dibyl H, and dibyl H also reduces ester into aldehyde, okay. So it does not reduce ester, it reduces only one acid derivative, that is acid chloride or acid halide into alcohol. It changes imine into amine, it changes azide into amine, okay. Apart from this, it reduces 3 degree alkyl halide into alkane, that is R3CCl is converted into R3CH. One hydrogen is attached at the place of chlorine. Similarly, it also converts tosyl hydrazone into alkane, okay. Suppose if this group is present, then this group is converted into CH2. This whole group is called tosyl hydrazine. When it is attached with carbonyl group, it is called tosyl hydrazone. So it also converts tosyl hydrazone into alkane, okay. Alkyl halide and tosyl hydrazone, two groups are converted into alkane. One more group is there. If diazonium borofluorides are available, then they are also converted into alkane, that is, that group is replaced by hydrogen. What is the name of group? One more group is there, diazonium borofluorides, okay, and this group is C6H5N2BF4, okay, N2BF4. So when it is treated with NaBH4, this is converted into C6H6. This whole group is replaced by hydrogen, okay. So there are three groups which are replaced by hydrogen. One is tertiary alkyl halide. Once again we will be discussing the reactions of NaBH4. It is a very weak reducing agent. It reduces aldehyde into 1 degree alcohol and ketone into 2 degree alcohol, acid chloride into alcohols, okay, imine into amine and azide into amine. 3 degree alcohol into alkane, that is halogen is replaced by hydrogen. Tosyl hydrous zone, that tosyl hydrous zone group is replaced by hydrogen, and diazonium borofluoride, this group is replaced by hydrogen when it is treated with NaBH4. Now there are some reactions which are not, there are some groups which are not reduced by NaBH4. These groups are, the groups which are not reduced by NaBH4 are carbon-carbon double bond, carbon-carbon triple bond, carbon-nitrogen triple bond, okay, carbon-nitrogen triple bond, and ester group, acid and its derivative carboxylic acid. Acid means carboxylic acid, amide. These are not reduced by this weaker NaBH4. Okay, nitro group. So these groups are not at all affected by this NaBH4. Okay, NaBH4 is a milder reducing agent and it does not reduce these groups. Okay, so double bond, triple bond, cyanide, acid, ester, acid derivative except acid chloride because it reduces acid chloride, and nitro groups are not affected by the NaBH4. How it reduces any group? What is the mechanism? Let us see how it works. So what it does, NaBH4 has 4 hydride groups. So NaBH4, it breaks down into BH4 negative, and one by one all the hydride ions, they are given by the NaBH4, and it reduces aldehyde and ketone and other molecules by transferring hydride ion. Okay, so by transfer of hydride ion, it reduces aldehyde, ketones and other functional groups which we have just discussed. Now if conjugated carbonyl group is there, suppose conjugation is there, so it does not reduce conjugated carbonyl groups. Conjugated carbonyl groups are not reduced. For example, if I take CH3, CH, double bond CH, CO, CH2, CO, CH3. So this is conjugated and this one is not conjugated. So when you treat it with NaBH4, okay, so this conjugated one will not be reduced. So you will get CH3, CH, double bond CH, C double bond O, CH2, and this one group will be converted into secondary alcohol. So conjugated groups are not at all affected by the NaBH4. So for the carbonyl to be reduced, it can differentiate between conjugated and non-conjugated carbonyl groups. Now if we take beta aryl alpha beta unsaturated carbonyl compound, okay, so what happens with beta aryl means C6H5 CH, double bond CH, single bond CHO. This is beta aryl alpha beta unsaturated carbonyl compound. When you treat it with NaBH4, it undergoes direct addition. Okay, means this double bond will not be ultimately affected, and you will get C6H5CH, double bond CH, single bond CH2OH, right? Okay, and again, if I take this one, this is beta alkyl, alpha beta unsaturated compound. When this one is treated with NaBH4 in presence of CeCl3, it will give this product. It will give this product. Okay, so this is the direct addition of hydride ion given by the NaBH4 on the alpha beta unsaturated compound. If in this case, if we do not use CeCl3, if this CeCl3 is not used, if we use only NaBH4, so ultimately what we get this one, and which ultimately result in this one. Okay, so first it gives conjugated addition. This is conjugated addition, and then direct addition. Okay, you might have read about this. If not, then we will be discussing in some other lecture. Alpha beta unsaturated compound, two types of addition can take place. One is conjugated addition and other is direct addition. Okay, so normally it does not affect the double bond. You can say in case of alpha beta unsaturated carbonyl compound, here you can say, here you can see it, this is alpha beta unsaturated, the double bond is not being affected. Here also in presence of CeCl3 it is not affecting the double bond, but if we are not using CeCl3, we are using only NaBH4, then in case of beta alkyl, this group is alkyl group. Here at the beta position there is aryl, here at the beta position there is alkyl. So beta alkyl can reduce double bond also. Okay, first conjugated attack takes place, and after that direct addition takes place, and double bond is also reduced when it is beta alkyl alpha beta unsaturated compound. Now the other things remains as such, and we get the reduction after NaBH4. One NaBH4 molecule, it will give 4, or it can reduce 4 carbonyl molecules, or aldehyde molecules, or ketone molecules. Thank you. In the next lecture we will talk about LiAlH4.